the third section of chapter 4, which was about experiments. Good ways, bad ways to do experiments. Today is section 4.4, and this is the last section of chapter 4. And so once we get through this section, then chapter 5 starts in on everybody's favorite, probability. Alright? So expect there to be a big shift in the way that you have to study for this class once we start probability. Up through chapter 4, it's a lot of vocabulary and terminology and concepts from reading, so you have to be very diligent and do the reading and study the words. Once we get to chapter 5, it's a lot more computations and not just plugging stuff in a calculator, but you have to really think about the problems a little bit to figure out, the right way to solve them. So things are going to switch a little bit after today, but today is kind of the leftover stuff from design of studies that didn't make it into one of the previous sections. So this section deals with both surveys. I said both, and then I'm going to say three things. So it deals with three things: surveys, observational studies, and experiments. We have a little bit from each of those things that we need to talk about today. So, first thing we'll start with is surveys. And different ways to collect or to draw samples for surveys. She told me I was supposed to use my own eraser. Apparently those got ruined. So here we go. Surveys. How do you get the sample that you need for a survey? Well, we've talked about several different ways at this point, so let's do a real quick review. We've talked about random samples, right? We've talked about simple random samples. Now, remind me what a simple random sample is.
All groups can be in the sample.
Okay, exactly. All possible groups from the sampling frame that could be together are just as likely to end up together, right? So every group in the sampling frame has an equal chance of being selected. What's a convenience sample? We've talked about that one a little bit. What's a convenience sample?
People that just walk by and you say, hey, want to do my survey randomly, but
Yeah.
not really random.
Yeah, it's never really random. Convenience sample is basically exactly what it sounds like. You take whoever's convenient for you to survey, right? What kind of a sampling scheme did you use in your survey that you did for this class? Remember the sample of size 5 that you had to do? Convenience. I can guarantee you, statisticians never say they're 100% sure of anything, but I'm 99% sure that every single one of you used a convenience sample. Now, you didn't do any kind of random selection to decide who was going to be in your survey. In order, if you had done that, what would you have to do? How would you do a random selection of 5 people?
Pick a population.
Say it louder.
Pick a population.
Okay, first thing you got to define your population, which we really didn't do. I just said sample 5 people. Right? But so pick a population, then what?
And then you have to somewhat number the population and then randomize it.
Okay, somehow number every individual in the population, and then use some kind of a random number generator to give you 5 numbers from that. And then you contact those 5 people and hope they say yes. That's how you would get a random sample. Is that a simple random sample?
No.
If we did what we just described. Yeah, that's a simple random sample. If you number all of them, we'd have to define our population. Is it Washburn students? Is it all college students? Is it all adults? What is it exactly? So we didn't really do a good job of defining our population, but if we did, we'd have to be able to assign a number to every single person in that population. Then using our calculator to sample 5 of those would give us a simple random sample. So those are the things that we've talked about. One other, we've also talked about a voluntary response sample. Good or bad? Bad. voluntary response are bad. Yeah, you have a question?
Didn't with the age cutoff you kind of set the population for us, except for those couple of people who
Yep,
did?
I did narrow the population. I said you had to be 18 years old or older to be in the study. But I didn't say they had to be a Washburn student. I didn't say they had to be a college student at all, right?
That's basically all adults.
Right. So basically, it's anybody older than 18 was eligible for you to pick, right? But that's a tough sampling frame. These are bad. What kind of people, what kind of study is a voluntary response study? Okay, it can be a poll, but what's the, I mean, you can have random polls too.
People have to volunteer themselves to respond. You could
Okay,
set up something online, like a poll, and people have to willingly respond to your survey.
okay, exactly. You just put the poll out there somewhere where lots of people will see it and say, hey, please take the poll, click on this button on the internet, or mail this card back in, or whatever, right? That's a voluntary response. And who is likely to respond to a voluntary response sample?
People that have a strong opinion on the subject.
People who have a strong opinion about the subject. Those are the only ones that are going to respond, right? Everybody else, you don't get, so you get a biased sample. So don't trust results from most voluntary response samples. Okay, so a couple of new ones today. First one we'll talk about is a stratified sample. A stratified sample is a random sample. Everybody in the population has an equal chance of being selected. Okay? But it is not a simple random sample. It's more complicated than simple. Right? So here's how a stratified sample works. You divide your sampling frame, in other words, your population, into groups based on some, usually a categorical variable, so I'm going to go ahead and write that, although it technically wouldn't have to be categorical, but based on some categorical variable. Then draw a simple random sample, which I call SRS. Draw a simple random sample from within each group. And those groups are called strata. Now, what does that word strata mean? What does the word stratify mean?
Isn't it the individuals in that group or the
Okay,
sets of
yeah, that's what we're doing, but just English language, what does the word strata mean? Anybody know? Okay, geology? Layers, means layers. And essentially that's what you're doing, although you're not stacking people up, right? But you're saying, okay, here's a variable, maybe that variable is health rating, right? So I use as my stratification variable health rating. And I say, well, I want to do a survey, but I want to make sure that I have people who are in poor health and people who are in excellent health and an even distribution. So I randomly sample, I take everybody who's rating themselves a 1, poor health, and I take a random sample of those people. Maybe I get 10 of those people. Then I get 10 2s, 10 3s, 10 4s, and 10 5s. Okay? So I end up with a sample size 50, but they're evenly spread across the levels of my stratification variable. That's a stratified sample. Okay? So here's a quick example where you might use a stratified sample. Suppose I was interested in doing a research study on how well you do in my class based on where you sit in the classroom. Because here's my theory. See, my theory is people that sit up front, they're the good students. Right? They're the ones that are really on top of things. They want to pay attention. They, they're really on the ball. And the people in the back, they're really only here to take a nap. They don't care. They're just here because they got to get that check box that says they took this gen ed class, and they don't care anything about doing a good job. Right? That's my theory. So if I take a simple random sample, say, well, I'm going to study 5 people from this room. If I take a simple random sample, what could happen?
Could get everybody from the front of the room.
I could get everybody from the front row, right? If I do a stratified sample, how would I do that?
Take, divide it in different parts of the room and then randomize it from
Okay.
those.
Very good. Divide maybe by rows. Looks like we have 5 rows here. There's a 6th row, but nobody's in it. So I got 5 rows, and say, well, I'm going to take a simple random sample from within each of those 5 rows. So maybe I select 2 people from each row, and that's my sample. Okay? That's a stratified sample. It helps to make sure that you have all groups represented. You don't have, and this is one of the terms from a previous section, you don't have undercoverage from some of the groups. Okay? A common stratification variable is gender. A lot of times you want to make sure that you have equal representation, males and females, so you stratify your sample by gender. Another one is race. Particularly if you have some kind of a questions in your survey that involve race, you may want to make sure that you have an equal representation of the different races in your survey. Right? Now there's 2 ways you can think about doing that. You could do it equal, where you say, well, I want a sample of 200 people, and I want them evenly distributed across, say, 4 races. So I get 1/4 of my sample come from white, 1/4 come from black, 1/4 from Hispanic, and 1/4 from other. Right? But what happens there is that sample representative of the population? No, so it matters on what you're trying to do with the results of your survey. If you're trying to say, in the general population, what's the percent of people who favor this legislation or whatever, then you probably wouldn't want to do it that way. Particularly if the opinions on that legislation are race related. That different races might answer the question differently. Right? So what's another way you could do your stratified sample? Instead of saying 25% come from white and 25% from black and so on, get statistics about the population. Say, well, in this population, it's 80% white, so take 80% of your 200, take from white. And then say it's 15% black, take 15% of your 200 black, and so on. So you do it, it's called proportional sampling. You do proportional sampling from your strata. Then it matches the population demographics, and it's a better representative sample. And you actually can do better with a sample like that than you can sometimes with a simple random sample. Because a simple random sample is, it's probably going to kind of mimic the percentages in the population, but by random chance, it could be fairly far off. If you want to force it to mimic the population, then you do a stratification. Okay, next kind is called a cluster sample. And the definition of cluster sample confuses people in, well, how is that different than a stratified sample? So let me write it out, then we'll discuss it, and we'll see, well, where is the difference? A cluster sample, you divide the frame into groups, and this time we don't call the groups strata, we call them clusters. But then here's where the difference occurs. And then draw a simple random sample of clusters and survey all subjects in chosen clusters. Okay? Divide the frame into groups, then draw a simple random sample of those groups. Then once a group gets chosen, you survey everybody that's in that group. So where's the difference between a stratified sample and a cluster sample? Well, it's where the randomization occurs. In a stratified sample, the randomization occurs at the individual level within a group. In a cluster sample, the randomization occurs at the group level, not the individual level. You randomly sample groups. So where might this be useful? Suppose I want to give a survey to Washburn University students. I could do a simple random sample. I could do a stratified sample, and maybe I say, well, my grouping variable is going to be what classroom they're in. Right? So let's say I just pick 12 o'clock classes on Monday, Wednesdays, and Fridays. Right? And I'm going to go around to classrooms on a particular Friday at 12 o'clock, and I'm going to survey people. If I do a stratified sample, my grouping variable is classrooms. I go into each classroom, every single classroom that's in session that hour, and I draw a simple random sample of the people sitting in that classroom. So maybe I pick 3 people from the class, and they have to take my survey. What would a cluster sample look like? What's that?
Each classroom that you choose would have to, everybody in the classroom.
Okay, I survey everybody in the chosen classroom, but I don't go to every classroom. I randomly sample some of the classroom. So think about taking the room number. So this is, what is this? Room Morgan 278. So Morgan 278, I write it on a slip of paper and I put it in a hat. And I take every classroom that's in session or being used at that particular time, and I put all those classrooms on a slip of paper, put them in a hat. I reach in, I pull out 10 of them. Then I go to those classrooms and I survey everybody that's sitting in the room. That's a cluster sample. You see the difference? Subjects come in clusters. Usually those clusters are defined by some location variable, like classroom, but it doesn't have to be. So usually clusters are by location. And this is a common strategy for doing large surveys where your clusters might be cities or counties in a state. Right? So you say, well, I'm gonna look at all 50 states, but I'm going to randomly sample 5 counties from the state. In Kansas, there's 105 counties. So you wouldn't want to stratify by that because you'd have to go visit every single of those 105 counties. You've got a lot of travel. But if you can randomly sample 5 counties, you only have to go to those 5 counties, but then you survey a lot more people from those 5 counties than you would from all of the others. So usually clusters are defined by location, but they don't have to be. They do studies sometimes like in animals, like think about a study in dogs. You might take a litter of pups as a cluster, right? And you take the whole litter and you study that rather than go find puppies from, a single puppy from all over the place. So it doesn't have to be by location, but usually it is. In a sampling or a survey situation, that's usually that way. Okay? Let me read you a scenario. A researcher is planning a survey to estimate the proportion of employers in the United States that do not offer health insurance. She wants to study how the results depend upon the type of company for which a person works. Suppose she considers 3 types of companies: individual owned with less than 50 employees, individual owned with more than 50 employees, or a publicly traded company. That's a big corporation or whatever. Okay. And then it says she can take a simple random sample of 100 companies from each type. Is this an example of a stratified sample or a cluster sample? I heard 2 people answer, and I heard a lot of silence. Is this a stratified sample or a cluster sample? Sampling companies, right? It says a simple random sample of companies. Are we surveying every person in those companies that are selected?
No.
No, if we were, then I'd have to start thinking, well, that's maybe a cluster sample. But we're not. We're just asking, the company as a whole, do you offer health insurance? So it is a stratified sample. You've divided your companies into 3 groups, small, medium, and large companies. And then you take a simple random sample of 100 from within each of those groups. So the randomization occurred within the group, therefore it is a stratified sample. Okay? That's easy, isn't it? It's not always so easy to read a paragraph and figure out, oh, this is cluster, or this is stratified. So you'll need to practice that. You'll have some homework problems like that. I can almost guarantee you will have a test question like that too. You have to read a scenario and figure out what kind of sampling scheme was used. Okay, this section also covers a few terms that we've already done, so I'm not going to repeat them, but I will just talk about them to remind you as a bit of review. Talks about types of observational studies. Case control studies, cohort studies, and cross-sectional studies. Okay, now what are the differences? What's a case control study?
You match people with like a given condition to the control person who does not have a condition.
Okay, exactly. You have cases, which means they have a case of the disease, whatever the condition is that you're interested in. You select them to be in the study based on whether or not they have that condition. And then you ask them, let me ask this question, is that a prospective or a retrospective study? Retrospective, very good. Because you have to ask them, okay, in the past, tell me about your cell phone use or whatever it is. Okay? What is a cohort study?
Study it over time.
Okay, it goes over time, and you select them to be in the study not based on whether or not they have the disease. In fact, you don't want anybody at the beginning of the study to have the disease. You want to follow them through time and see who develops the disease. And then follow them through time and see who chooses what habits, right? Do they have a good diet? Do they smoke? Are they exposed to this chemical? Whatever, through time, then does the disease develop? That's prospective. What's a cross-sectional study? Give you a hint. It's neither of those. It's not retrospective. It's not prospective.
Is that at one point in time and longer?
It's at one point in time. You do, basically, they're generally questionnaire kind of studies where you bring somebody in, you ask them a question, what are you doing right now? And then maybe you test them for a disease, or you ask them about that disease or whatever. I gave an example that had a picture of this obese kid on it and said, I can't even remember the study now. It said, is something making our kids...
Common cold.
Common cold, that's what it was. Is the common cold making our kids fat? Remember that one? And it said right in there, this is a cross-sectional study. And so that's telling me they did the study by checking the kid on that day, are they obese or not? So they took weight and height and computed BMI, classified them as obese or not, and then have you ever, or do you have the cold? Or do you have a cold? Right? So it's a cross-sectional study. Okay? So that's the review of those three. And, like I said, we've done those before, so I didn't write them on the board and go into it too much. But next thing I want to talk about is blocking. And blocking is used in experiments, not in surveys, not in observational studies. Well, actually, you could. There are some observational studies, particularly cohort studies, that do use blocking, but that's actually fairly rare. Isn't that cool? It's magnetic. But I've never had the real reason to leave that stuck to the board, so I don't exactly take advantage of it. So what do we mean by blocking? Well, blocking is a block of experimental units is a group that is similar, that are, is that a group of experimental units that are similar based on, I'll say lurking variables, because I think that's the way you'll best understand. It doesn't have to be lurking variables, but just you want to group your experimental units together that are similar to each other. Okay. Here's a quick example. Suppose I'm interested in whether fertilizer A or fertilizer B is the best fertilizer to use on the kind of wheat that I grow. Okay? So I find a farmer down here about 30 miles south of Topeka who has 30 acres of land that he's willing to let me grow wheat on for a season. So I have me this plot of land, and then, I had a statistics course back in college, so I know that if I'm going to do a study, I need to have a control group, right? So I find another farmer that's about 30 miles north of Topeka, and I plant 30 acres in wheat up there. And down here I put fertilizer B, and up here I put fertilizer A. First of all, is this an experiment or is it an observational study? It is an experiment because I've imposed a treatment on the wheat, right? Is it a good experiment or a bad experiment?
Bad.
Bad experiment. What is my experimental unit here? Remember I didn't write it down. What is the definition of experimental unit? What gets the treatment? It's the thing to which treatment is applied. So what is my experimental unit? The farms. This whole farm, that whole farm. Right? Design a better experiment.
Put a
A
third.
and B for north and A and B at the south.
Okay, put A and B both up here, and A and B both here. Okay. What could go wrong with this experiment? I heard the weather. What'd you say?
The soil will be different.
Okay, soil could be different. In fact, almost guaranteed they will be different, right? 30 miles south of Topeka, 30 miles north of Topeka. So soil would be a lurking variable that could screw this all up. And you said weather, so amount of rainfall, how harsh the winter is, stuff like that.
Bugs.
What'd you say?
Bugs.
Bugs, okay. Could have a different density of bugs. Anything else?
The farmer, what they do to it?
Okay, the farmer, yeah. If I just give them seed and I give them fertilizer and I don't control that part of it myself, then that could be a looking variable. There's one other kind of a big one that I'm thinking of. How about terrain? Like maybe this farm is in bottomland down by a creek. This is up on a hillside. It's rocky. It's your soil gradient or soil fertility, but also the gradient of the thing, right? You have different quality or different amounts of yield just based on that alone. So that's another looking variable, the terrain. So design a better experiment. Well, instead of using the whole farm as one experimental unit, let's chop it up into pieces. Maybe I say, well, let's go into fourths. And then each farm represents a block of experimental units. Because all of the 4 parts of this 30 acres ought to be pretty similar across these lurking variables. So when you group experimental units that are similar, that's called a block. So this is one block, this is another block. Now within each block, I assign all of the treatments. In this case, I only have 2 treatments, so I make sure that I randomly assign the treatments to the experimental units within a block. Much better experiment. Yeah.
But wouldn't you want a control group that didn't have fertilizer on it, or?
Well, not necessarily. Possibly, yeah, that'd be a good idea to have a third treatment that's no fertilizer at all. But, you know, the way I worded the scenario was, I just want to know which of two fertilizers is the better one. So I'm gonna run this study, and then I'm gonna sum up the yield per acre, you know, bushels of wheat per acre for the 4 experimental units that got A and for the 4 that got B, and get an average yield per acre, right, and compare those two. I forgot to do it, but the other day, well, a couple weeks ago, I was out driving through the country, heading to my folks' house, and I passed a field that it was a cornfield, and I thought, ooh, there's my blocking lecture. I didn't have a camera with me. I was gonna go back and take a picture of it, because out along the road, there was every about 10 rows of corn, there was a new sign sticking up. You ever see these?
Oh, the test plot?
The test plots, yeah. And that's what they're doing. They're dividing their plot into blocks. Only typically those blocks are what they call strip plots. So they take a field, and instead of dividing it into the squares, it's like this. And why would they do that?
The rows, they get more different kinds.
Well, yeah, you can get more different kinds, but
How
just
when you
it's
harvest
easier.
it.
Yeah, if anybody who grew up on a farm, how do you plant corn? Well, you load your planter, and you go down, and you turn around, and you come back. Well, if you had to stop here, it's harder to get the different treatments. So it's one long strip, and then each 10 rows was a whole different variety. And they must have had 20 different varieties in this plot that I went by. There's a field trial going on. So that's what they're doing. They're using blocking. Okay. Now, what about human studies? Can you block human studies? Can you group experimental units that are similar? Yeah, describe me a scenario.
Maybe you're doing a study on something that you'd need to group people by, like socioeconomic status.
Okay.
Um,
Socioeconomic status. Those that are in the same socioeconomic status level would be grouped together, known as a block. That sounds a lot like stratification, doesn't it? And it is. Essentially, blocking in an experiment is the same thing as stratification in a survey. In fact, when we do clinical trials, a lot of times we'll write it that way. We'll say we are going to stratify the randomization by gender, by disease severity, or whatever else. But remember, an experimental unit does not have to be a person in a human study. Remember the example with the 2 eyes and the contact lens? Right? Then you have a right eye, left eye. Your experimental unit is an eye. What would your block be in an experiment like that?
Could you say like the prescription for contacts? Like each one could be different?
Possibly. That's not what I'm thinking of. But which 2 experimental units are going to be the most alike? So here I have 100 people, which means I got 200 eyes that I can put solution in. The 2 eyes that come from the same person are going to be very similar for all those lurking variables. So the person becomes a block. The experimental unit is part of a person, so the person becomes the block. Okay? That's what's known as a matched pairs design. It is a type of blocking, but the block is size 2. Okay. So the pair might come from within the same individual. Have you ever heard of identical twin studies? Yeah, those are fairly common. And that's a matched pairs design. And they don't have to be identical twins. You can match people just based on certain personal characteristics. Like I've got a 45-year-old male who smokes. So I find another 45-year-old male who smokes. and I randomize one of them to placebo, one of them to active. That's a matched pairs design. Okay? There's another type of matched pairs design that's even better than a twin study, and that's called a crossover design. Has anybody heard of this? Have you heard of a crossover design? What does that sound like? Crossover.
Isn't that where they do one kind of treatment and then they go to the next treatment?
Exactly. They start on one type of treatment, then they cross over to the other treatment. Or if you have 4 treatments, they might have 4 periods. You get treatment A for week 1, treatment B for week 2, and so on. In a crossover design, it is a type of blocking. And what is the experimental unit? Suppose I'm doing an allergy study. And allergy studies are sometimes done as crossovers. So I do an allergy study and I say, okay, I'm gonna randomize you into my trial, and you're going to be in the trial for 3 weeks. The first week you'll be on either placebo or active medication. The second week you'll be in what we call a washout period to let any effects of the drug wear off. And then the third week you're going to go on to the other treatment that you didn't get the first time. That's a crossover thing. I'm not going to tell you which treatment you're on at any time, so it might be placebo, it might be active, but whatever you got the first time, you'll get the other one the second time. That's a crossover design. What is the experimental unit? Each person. What's the block?
1 times 1 week. No.
No, it's not the week, because everybody in the study has week 1, so you'd have one big block. It's kind of a trick question. What? It's the person. So the person is the experimental unit. So, well, wait a minute, a block is supposed to be a group of experimental units. Well, it is, sort of. It's a person at week 1 and then that same person at week 3. Those 2 different times. So time becomes the factor that distinguishes between one experimental unit and another, not the person. So the person gives you 2 observations, and those 2 observations are blocked together. They are paired. This is a type of matched pairs design, which therefore is a type of blocked design. Okay? Suppose I was interested in studying whether or not your pulse, when measured sitting, like you are right now, is it different than pulse measured when you're standing up? Design me an experiment to do that.
You study them sitting down, and then you give them a break period, and then the next time you do it standing up.
Okay? You just described a crossover design, right? Would this also work? I randomly divide you into 2 groups, and I have group A sit down, and I have group B stand up. And I take the pulse from the 2 groups, and I average them, and I compare those means.
Only if you did a baseline.
What's that?
Well, you'd have to, it wouldn't really work necessarily, because the people that were standing may have higher pulse to start with, or lower to start with.
Okay? It is, that's exactly the right concern. It is a valid thing to do. I can compare the mean of those who are standing with the mean of those who are sitting and say, look, they're different, or no, they're about the same. But you have more of a problem with lurking variables, and more of a problem with just patient variability, right? Whoever has the lowest pulse in this room, I don't know who that is, but whoever it is, let's say their resting pulse is 50 beats per minute. Pretty low, right? If they happen to get randomized into the sitting group, what does that do? It pulls the mean down in the sitting group. It makes it look like there's maybe a bigger difference than there really is. If they happen to get randomized into the standing group, it makes it look like there's a little bit less difference than there is. If I do the crossover design, what happens? It controls for that lurking variable because each person serves as their own control. I now don't care what his pulse was. I don't care that it was 50 and when he stood up it was 55. I care that he changed by 5, and that's all I care about. It's the difference now that we care about when you do a crossover design. Okay? Now, crossover designs don't always work. They work in that example, checking pulses. They work pretty well in allergy studies, right? Because if I take the drug away, your allergy symptoms come back. I'm not changing the disease, I'm just changing your symptoms. Right? Give me an example where a crossover study wouldn't work. Antibiotics, great example. Okay? You've got a big old hairy infection on your arm from a wound that you got. So I'm doing an antibiotic study. Right? If I do it as a crossover, then whatever treatment you get randomized to for the first period, it works. And it cured your infection. So now it's time to do the second treatment, cross you over. You don't have an infection anymore. So I guess I'm going to have to cut your arm back open, put some bacteria in there, get a good infection going, and now we'll see if the other drug will cure you. It won't work. So if you change the underlying disease, you can't use crossover. If you're not treating the disease, but you're just treating symptoms, crossovers work. Crossovers are used a lot in allergies. They're used a lot in analgesics, like headache, right? An analgesic means it relieves pain. So you take the drug away, the pain comes back. So the next time you get a headache, we cross you over to the other drug. So crossovers work well in that. But anything where you change the underlying condition with your treatment and it won't come back to baseline, then you can't use a crossover strategy. Okay. So they're really good, really powerful designs if you can use them. But if not, then they don't work so well. Okay, the last topic in this section is multi-factor experiments. And so what do we mean by a factor? A factor is usually a categorical explanatory variable. There was an article published back in the early 90s about smoking cessation, right, helping people quit smoking. And they used the patch, the nicotine patch, versus a pill. It's called Zyban. Have you heard of Zyban? It's a quit smoking drug that you take. There's others out on the market now. And they used this example in the book. And I actually used this paper that was published over this study as an example when I taught at KU Med Center for the medical students. So it's a common example that gets used for factorial study and multi-factor experiment. So the categorical explanatory variable that I'm talking about is what type of product you use. Do you use a patch or do you use a pill? Right? So each factor then has two or more levels. So if I'm doing this study on smoking cessation, I might say, well, I'm going to randomize you, and you're either going to get a patch or you're going to get a placebo patch. So it's a patch you stick on your arm, but it doesn't have any nicotine in it. Okay? So I have one of my factors is the patch, and it has two levels, either active or placebo. The other factor in the same study is the pill. And that's also active versus placebo. So this study is known as a 2x2 factorial design. So what I do actually, I mean, you can think of drawing like, it's almost like a contingency table, only it's not counting people that answer a certain way or anything like that. It's just where did they get randomized? And I do pill, active, placebo, and then patch, active, placebo. And let's say I have 200 people total to randomize into my study. If I decide to randomize them evenly, I might put 50 people on each of these 4 treatment combinations. So here's 50 people who got active pill and active patch. They get both factors, right? Both treatments. These 50 people, they get an active pill, but they don't get any nicotine patch. They get a placebo. These poor people, what do they get? Nothing. They get placebo of both of them. Placebo, placebo, right? Well, this is called a factorial design. What does a factorial design let you do that you can't do with a regular design? Right? I got 2 different things I want to study. Does the pill help you quit smoking? That's one thing. Does the patch help you quit smoking? That's another thing. I got 2 things that I want to study. With a factorial design, I can put both of those things into a single study. What's the advantage of that instead of just doing 2 separate studies? Let's do a pill study, and then let's do a patch study.
You can see if they work together or if they work separately of each other.
Exactly. You can see, does the pill work better if they also get a patch? So I can compare these 50 people. They both groups got the pill, but half of them got patch and half of them got the
Placebo?
placebo patch. So I can compare that difference, and I can also compare this difference. That's called interaction of the 2 factors. If the 2 factors interact, then maybe one of them doesn't work very well if it's by itself, but when you add the other factor, it works really well. So the pill works really well if you give them a nicotine patch, but if you don't, it doesn't seem to help very much. That's called interaction. A factorial design lets you check for interaction, whereas doing 2 separate studies, there's no way to ever test that. So that's another way to make an experiment a better experiment. Okay? I got 1 minute left, so I'm going to read this to you. A survey of 1,314 women, in which each woman was asked whether they were a smoker. This study was done in 1972. 20 years later, a follow-up survey observed whether each woman was deceased or still alive. Was this study a retrospective study or a prospective study or a cross-sectional study? Prospective. We surveyed them in 1972, and then we followed them through time until 20 years later, and then we find out some more information about them. So we follow them forward through time. Right? That is a prospective study. So expect problems like that on the homework, where they're going to give you a scenario and ask you what type of study design was it. And like I said, you'll have some questions like that on the test too. All right. Have a great weekend, and we'll see you Monday. You have 4.3 homework due tonight by midnight, and then 4.4 homework will be due Monday by midnight.